Okay, so last part of chapter 5. Not a real big deal. Go through this quickly and get you down to the lab. I really think we'll be in the lab after. Okay, so what this has to do with is modeling with quadratic functions. So in other words, if we're given some information about a quadratic function, can we use that information to build a quadratic model? Okay, so and this is similar to, so for example, let's first of all quickly run through the three forms of quadratic equations, going back clear to 5.1 is when we first talked about this. So we said standard form is kind of the normal form, y equals ax squared plus bx plus c. What were the other two? Anybody remember? We had standard form, and then we had two others. Vertex form and that's vertex. So what is vertex form? Y equals, that's the one with the vertex, and what are the coordinates of the vertex? Do you remember? H and K, just like it was with absolute value functions, right? The vertex, and whenever you have functions that have a vertex, and lots of functions do have vertices. So if you have, like, for example, later on, if we get a chance, we'll talk about some hyperbolas and things like, and there's lots of different kinds of functions. If they can have a vertex, then the vertex, we reserve the variables h and k for that always. Just like we did with absolute value functions, just like we did with parabolas, quadratic functions. So it was y equals what? Remember? H and k were the vertex. Remember that? A times the quantity x minus h squared plus k. So A means the same thing. A mainly just tells us, is it opening up or down, right? H and k give us the coordinates of the vertex. Just like with the absolute value function, remember one of the things that we dealt with here is that the h is being subtracted from the x. So if we had something like x plus 3 quantity squared, what is h? Remember that stuff we talked about? If we had an example, like if we wanted to say sketch a graph of this, what if we had y equals negative 2 times the quantity x plus 3 squared plus 4. So does it open up or down?
Down.
Down. Okay, now where is the vertex? HK. What's the value of k is easy. What's k? 4. Okay, so we know the y coordinate is 4, but what's the x coordinate? What's h? What is it again? Negative 3. It's always the opposite of that operation, isn't it? The sign is opposite of the operation because we're subtracting h. And x minus negative 3 is equivalent to x plus 3. Right? So that would have been our vertex. And that's, as you go through it, you'll remember that stuff. And then the other one, last one was, I haven't done as much with this one really. Yeah, I heard it. Intercepts form. Right? I heard it. So intercepts form, A means the same thing, only this time it just looks, and really the way to think about this one, now that we've gone through the whole chapter, intercepts form, it's an okay name, but a better name is factored form. It's just factored, right? We've got this quadratic function that's been factored, and we know that if we want to find the zeros of this thing now that we've done some work, 5, 2, and so on, that we just set the factors equal to 0 and solve for x to find the zeros or the x-intercepts. So in this case, P and Q represent the x-intercepts, right? Okay, so when we do problems like this, I'm going to just do a quick reminder of some stuff that you've done that is very similar. This acts as a good kind of a springboard or a model for what we're about to learn. Remember what we did back in chapters 2 and 3 and even 4 a little bit. We were finding the equation of a line through 2 points. If they gave us 2 points, what was our strategy for finding the line y equals mx plus b? Say it again. Okay, good. So we're going to find m, right? We're going to calculate m because we know the coordinates of the point. So it's just going to be y2 minus y1 divided by x2 minus x1. Change in y over change in x, right? And we could do that. So we get 7 minus 3 on the top divided by 9 minus 1, for example. Which gives us 4 over 8, which is 1/2. So the slope is 1/2. Now how did I find b?
Plug into 1.
Okay, good. I'll plug in m, and I'll plug in a value of x and y, because remember, what I'm really doing is I'm plugging into the equation y equals m, whoops, m x plus b. I just need to know the values of m and b, and I've got my line, right? I know what m is immediately, but to find b, I'm just going to plug in all that stuff and solve for b, right? Remember what I did? So I plugged in m, I plugged in either the coordinates 1 and 3 for x and y, or 9 and 7. In this case, 1 and 3 are smaller, so I'd use those. But they both work, right? And I plug those in. And if I plug those in, I'd plug in 3 for y, right? And I'd plug in 1/2 for m, and I'd plug in 1 for x. And then I just solve for b. So 3 equals 1/2 times 1 plus b. And so if I, they did that wrong, didn't they? Yeah. So we want to subtract 1/2 from both sides, not add. So that's actually wrong. That should be minus 1/2. And 3 minus 1/2 is 5/2, or 2.5. So, but you get the idea, right?
They messed up.
They messed up. So the answer, so the line would have then been, if we wrote down our answer, it would have looked like, oh, hang on, I guess we didn't. So our answer would have been, I never wrote it down. Our answer would have been y equals 1/2 was our slope, x, and then was it plus 5/2, right? Our job then is to put the variables back in. We just want to put in the values for m and b, right, the parameters. For a line, there are 2 parameters, m and b, but for a parabola, there are 3. A, for example, a, b, and c, if it's ax squared plus bx plus c, or a and h and k, if it's vertex form, or a and p and q, if it's intercepts form. We got to put in those 3 numbers, right? Okay, so same kind of a strategy. So if we know, for example, that a quadratic function, graph is a parabola, it has a vertex of -2, 1. What's that telling us right away?
It goes down.
No, you're thinking of a. If a was negative, it would go down. If this is the vertex, though, now let's write vertex form real quick. Y equals, what was it again? A times, good, quantity x minus h squared plus k. I just need to know, to get this quadratic function, I just need to know a, h, and k. If I knew those numbers, I'm done, right? We want to write this thing in vertex form, so I just have to be able to plug in those numbers. Well, which ones have they already given me? They give me h and k, right? I know that h is -2 and k is 1, so those are already taken care of. But they did not give me a. So, but however, they did give me something important. They told me that the parabola passes through a random point, not a special point. It's not a vertex or something like that, but it passes through a random point, 1, -1. How does that help us? Okay, it gives us a value of x and y that must work because that point sits on our curve, right? So it's a solution. So this would work. That's a value of x that works, and that's a value of y that works, right? And so I could plug those guys in for x and y, and then the only thing that's unaccounted for that we haven't plugged in is a, right? If I plugged in numbers for everything else, I can solve for a. That's the only unknown left, right? So let's see that. Let's see that happen. Okay, so there's our vertex form. Okay, we know there's h and k, there's x and y, right? And this PowerPoint's up on the site already, so you can go back and look at this later if you want. Plug that stuff in, and look, the only thing remaining is that a. So I just simplified. Well, what's 1 minus -2? 3. Squared would be 9. Okay, so I get -1 equals 9 times a plus 1. I could subtract 1 to that side and get my -2. Divide by 9 and get a equals -2/9. We got it. Now I know what a is, I know what h is, and I know what k is. So I can plug that stuff into standard form, and I'm done. There's my A. X minus negative 2 is x plus 2, plus k is 1. How about that? Okay, that's all we want. Just like we did with lines. The same strategy exactly works for a problem like this too. It's an intercept form. So we want to write a quadratic function in intercept form for a parabola with x-intercepts of 1, 0, and 4, 0. Well, that's a sneaky way of giving me some stuff, right? What's that giving me? If this is the form of a quadratic function in intercept form, what parameters did they just give me? I've got to fill in the blanks for A and P and Q this time, right? They gave me P and Q, right? P is 1 and Q is 4, or it doesn't matter, or vice versa. Those are P and Q though, right? And then here's just some other random points, so that's just X and Y. So if I plug that stuff in then, right, there's P and Q, there's X and Y. What do I get? Well, for Y I'm plugging in negative 6, for P I'm plugging in 1, for Q I'm plugging in 4, and for both of my X's I'm plugging in 2. Right? So I get negative 6 equals A times 2 minus 1 is 1, 2 minus 4 is negative 2. So negative 6 equals negative 2 times A. What's A?
Negative 3.
3. Positive 3, right? Negative 6 over negative 2. So A is 3. I already know P and Q. Just plug those things into my intercepts form and we're done. How about that? No biggie, right? So now, last case. So we did vertex form and intercepts form. What about standard form?
That's easy.
Standard form is actually the hardest, but I'm going to show you a trick. I'm going to show you a trick.
It's pretty hard.
Okay, standard form, the reason standard form is a little bit harder is because there aren't those special points that we've identified on the parabola. Like the vertex form is great. If I know the vertex, I get 2 of the parameters in that one point, right? But there aren't any special points on standard form. So it makes, in that sense, it makes it a little harder. So if I know that the parabola goes through these 3 points, and I want to get it in standard form, well, the difference here is those are all just x and y values. There's nothing special about any of those points. They're just points on the parabola. They might be a vertex, but we wouldn't know. Okay? So what I've got to do then is I've got to plug, well, kind of the more basic, longer version of this, without the shortcut I'm going to show you, is that I could just plug in x equals negative 3 and y equals negative 4 into y equals ax squared plus bx plus c and get one equation. Get another equation if I plug in x equals negative 1 and y is 0. Get a third equation if I plug in x equals 9 and y equals negative 10. Right, so there's my first one, there's my second one, there's my third one. Right, and I just get each of these by using one of the 3 ordered pairs for x and y. Look what I'm left with now. When I do that, in each of these 3 equations, I've still got my A and my B and my C. I don't know what any of those are yet. Still got 3 unknowns. But I could simplify this a little bit. Look, I could turn that into a 9 and a negative 3 and a positive 1 and an 81, etc. Right? And this thing looks like, now it starts to look a little better. It looks like this. Right? That looks like a 9A minus 3B plus C equals negative 4. That one looks like A minus B plus C equals 0. And that one looks like 81A plus 9B plus C equals negative 10. And what if I'm going to, this ought to look familiar. This looks like a linear system, doesn't it? Because the A's and the B's and the C's are not being squared. So if I just identify all of the coefficients and the constants, like we did before, doesn't this just lead us into the 3x4 matrix that you see here? Right?
Wow.
And so we can solve the linear system using our old tricks, using our matrix tricks. Right? We can just use RREF and get this answer. Okay? So let's, do you ever remember do we need to go through that?
No, that's
So you know that part. Okay, now here's the trick. So that's pretty simple. I mean, that's not that big a deal, but there's even a simpler way. This is, remember the trick I showed you guys when we were doing, if you had 2 points and you wanted to use the calculator to find the line through those 2 points, you could use regression to do the work for you. Remember that? Because if I put in, let me just remind you what I said there. If you put in a whole bunch of points and I do regression, it's going to find the best line that matches that whole scattering of points. It's probably not going to be a perfect line though. But if I just put in 2 ordered pairs, if I put in 2 points, there's a line that has to go exactly through those 2 points. So when I do regression, it's actually called a linear fit. It's not even regression because it's going to fit the line exactly to those 2 points. Well, how many points, and the reason the 2 was the magic number there is because it takes 2 points to exactly define a line. How many points do you think it takes to exactly define a parabola? 3, you're right. It takes 3. There is exactly, if I were to draw 3 points on the XY plane, just 3 random points, it doesn't even matter where they are. If I just draw 3 points like there and say there is exactly 1 parabola that could fit through those. And I don't know, it's a little harder to draw these than it is a line, but it probably would look something like, you know, sort of like, you get the idea. There's only 1 parabola that could possibly match all 3 of those points if they're different points. And the calculator has a lot easier time of finding that than I do. And so if you do quadratic regression instead of linear regression with 3 points, it will give you back the exact parabola in standard form. Yes, ma'am?
Could a parabola go like left?
It could, but then it could, but it wouldn't be a function then. It would be written like this. It's a good question. It'd look like this: x equals a y squared plus by plus c. Okay, and we actually will see some of that later. But it's a good question. When we get to later chapters, we'll look at that. So then, all we got to do, if it's going through these 3 points, is just do quadratic regression. Do you want to go through this, or do you think you got it? Remember what this would be. Just go stat, edit, put in the 3 ordered pairs, and make sure you're doing quadratic regression instead of linear regression. It's going to give you back the values of A and B and C. Okay? That's really a handy trick. But it's only going to work if you have 3 points, though. If you put in more than 3 points, it's just going to find the best fit parabola that matches the data the best, but not perfectly. Okay? Got it?
Yep.
Okay.
Page 32.